Okay, so now we are going to look at, in the previous class, we already learned about the add marks. Okay, so there are a few bits in add marks that you need to do a settings in which the VREF, okay, on the VREF, you need to know, okay, so this is the VREF here. Okay, so this VREF here it is used to determine, okay, your reference voltage. And then you have a marks here. Okay, there's this is a 5-bit marks in which this multiplex marks here is used to determine, okay, your ADC channels, either you want to use a single channel or with a gains. Okay, and last but not least is a EDLA. So this EDLA is used to put your ADC, okay, either it is in uh, the result of the ADC either is at right justified or left justified. Okay, now we are going to look at another register, okay, that you need to know how to do the settings here, which is ADCSRA. Okay, for the ADCSRA, so this is the things, okay, the registers that you need to know, okay, every time, or you need to set every time you do the going to use the ADC, which is first we are going to look at this bit here, bit 0. Okay, this 3-bit, okay, which is bit 0 until bit 2. Okay, so this is, we call it as a ADC prescaler select bit. So this ADC prescaler select bit is very crucial in order to determine your conversion, so that your ADC conversion, okay, is fall between the, okay, in the range of the acceptance frequencies. Okay, then we have the AD. So this is the ADC interrupt enable. So every time you're going to use interrupt ADC, so you can enable the interrupt ADC by set 1 to this bit here. Okay, and once you use the ADC as an interrupt, and whenever the interrupt occurs, okay, this okay, whenever the ADC conversion completes, so this ADIF here, this bit here will be set, okay, to indicate that the interrupt already, okay, the interrupt can be triggered because the ADC conversion has been complete, and then now the CPU can get the ADC value, okay, the digital value after we did the conversion. Okay, and then we have this ADSC. So this is the most important one, which is you need to start every time you're going to start the conversion, you need to put this bit here with 1. If not, okay, your ADC conversion will not start. And last but not least, bit 7 here, and then, so this is where you're going to enable the ADC. If you disable, you cannot do the ADC conversion. Okay, so this is the settings that you need to know every time you're going to use the ADC. Okay. Okay, moving on to this bit here. Okay, for the prescaler bit, which is inside of ADCSRA. Okay, we are looking at the bit 0 until bit 2. So this bit will determine the division factor between the external frequency and the input clock ADC. So this is the option that you can select from 000, which is this is a reserve for the 000, 001. Okay, you're going to use a prescale 2. 010, so this is you divided your clocks, okay, your frequency with a 4, which is this is a prescale 4. 011 with a prescale 8. 100 is a prescale 16. 101 is prescale 32, and then we have a 64 prescaler when you put 110 at this bit here, and 111 when you're going to use the prescale 1 to 8. Okay, so this bit here is used to select the prescaler. Okay, why are you going to select the prescaler? Okay, this is because for the ADC, for the AVR at Mega 32, particularly, ADC requires an input clock frequency less than 200 kilohertz for the maximum accuracy. Okay, so that's why you need to make sure that your frequency, okay, your clock frequency is less than 200 kilohertz. Okay, every time you're going to do an ADC conversion, okay, make sure that your Xtel is below than 200 kilohertz. If not, if bigger than 200 kilohertz, what happens here is the conversion accuracy might be less. Okay, if your frequency is less than 200 kilohertz, then the accuracy of the conversion analog to digital conversion is accurate. Okay, will be. Okay, so let's look at these examples here. How to determine the what we call here the prescaler. Okay, so given AVR connected to 8 megahertz crystal oscillator, so your Xtel is 8 megahertz. Okay, given that the Xtel is 8 megahertz, and you're going to find out what is the ADC frequency for the ADPS when you put 001 to this bit here, 100 to this prescaler here, and 111 to this prescaler here. Okay, so what you're going to do here is first thing first, we need to find out for the 001 what is the prescale. Okay, for the 001, the prescale is 2. Okay, you're going to use a prescale 2. Meanwhile, for 100, okay, this one here, you're going to use a prescale 16. Is it 16 or 8? 100. 16, okay, prescale 16. And 1111 is a prescale 1 to 8. Okay, so what you're going to do here is, okay, you already identified the prescale option here. Okay, so what you're going to do is first, okay, you need to find out the new F. So F new equal to your Xtel, which is 8 megahertz divided by prescale. Okay, by using a 2 prescale, okay, the value that you will get is 4 megahertz. Okay, which is 4 megahertz is greater than 200 kilohertz. So this one here is not valid. Okay, you cannot use a prescale 2 for your ADC conversion. Why? Because the value that you get after you do the prescale 2 is 4 megahertz. So this one cannot be used. Okay, what about if you choose the prescale 16? So 8 megahertz divided by 16, you will get 500 kilohertz. Again, okay, this value here is greater than 200 kilohertz. Okay, our target is less or equal to 100 kilohertz. So this is the frequency that we're going to use. Okay, so since this is a 500 kilohertz greater than 200, so this one also cannot be used. So this is a not valid frequency. Okay, and then next, okay, we're going to use the 1 to 8. So for the 1 to 8, 8 megahertz divided by 1 to 8, and you will get 62 kilohertz. Okay, so since 62 kilohertz is less than 200 kilohertz, then yes, you can use this prescale 1 to 8. Okay, for example, if the same crystal oscillator is used, okay, you need to find out what is the optimal prescale. Okay, previously we found out that 1 to 8 can be used, okay, for the prescale, but this is not the optimal prescale. Okay, so now you're going to find out what is the optimal prescale. How to do that? Okay, you need to find the frequency for each of the prescale option available in your ADCSRA. Okay, since 16 tak boleh guna, so why not we choose the 32? Can 32 able to produce a frequency less than 200 kilohertz? Okay, so now you press the calculator, 8 megahertz, okay, divided by 32. Okay, so this is another prescale that we can have, 32 followed by 64, and the last one is 1 to 8. 1 to 8, you after we did the calculation, we get to 62 kilohertz. So this one is scanned, but this is not the optimal prescale. Okay, what about 32? Okay, 32, you will get 200 kilohertz. Okay, since this 250 kilohertz is greater than 200 kilohertz, so this prescale also cannot be used. What about 64? Okay, so now we just divided 8 megahertz with 64 and we'll get 125 kilohertz. And this one here is less than 200 kilohertz, and you can choose this prescale as your optimal prescale. Okay, if you choose the 1 to 8 as your prescaler, then your answer will be wrong because this is not the optimal prescale. Okay, even though it gives you the less, what we call it, the less frequency. Okay, so this is how you're going to choose the prescale to make sure that the frequency that you obtain is less than 200 kilohertz for the maximum accuracy when you do the analog to digital conversion. Okay, and this one here, this is the step. Okay, in order to do the ADC programming. Okay, there are two methods here that you can use for the ADC programming. Okay, are the dual methods. Okay, the first method here we call it as first for the ADC. Okay, you can use either polling method. The second one here is by using the interrupt method. Okay, so there are two methods that you can use in order to program the ADC. First by using a polling, the second one by using an interrupt. So now we are going to look at ADC polling method. Okay, so this is the step that you need to use in order to do the ADC polling method. Okay, the first step here, what you're going to do here is you need to initialize your ADC input. Okay, so how to initialize your ADC input? Okay, since we have found that ADC input, the ADC channel is located at port A, so you need to make sure that your port A you make it as a input port. Okay, so make your port A as an input port so that you can put your sensors to use as a analog to digital conversion. So this is a step number 1. Okay, make your port A as an input port. Step number 2, okay, you're going to enable the ADC. Okay, so how to enable the ADC? Okay, first enable the ADC and select the conversion speed. Okay, to enable the ADC and select the conversion speed, you can do it inside of ADCSRA register. Okay, earlier we already learned that. So this is your ADCSRA register. Okay, I draw another time. One more time here. Okay, yang ni kamu punya ADCSRA. Okay, now we are going to enable the ADC. Okay, to enable ADC, you need to look at this bit 7. Okay, so this is where you're going to enable the ADC. Okay, bit 7. And to select the conversion speed, okay, you're going to look at this bit here. So this is where you're going to select the prescale. Okay, you need to do a calculation. Okay, based on the calculation and determine your prescale in order to make sure that the frequency is less or equal to 100 kilohertz. Okay, that is the second step. Okay, enable ADC at this bit here and select the prescale. Okay, in order to get frequency less than 200 kilohertz. Next, step number 3. Okay, you are going to select the VREF and ADC input channel. Okay, which is this is where you're going to put your sensors. Okay, if you're going to put your sensor at port A pin 0, so you need to select the ADC input channel at port A pin 0. Okay, how to do that? You can do this, okay, at this register called add marks. Okay, so inside of the add marks, okay, we have so this is your add marks registers. Okay, mula-mula, okay, we are going to determine the VREF. Okay, there are 3 VREF that you can choose from. Okay, so this is your VREF, which is at bit 7 and 6. Okay, so you can choose 3 VREF here, 0, 0, which is from AREF, 0, 1, okay, from VCC, and 1, 1, okay, which is your internal voltage, which is 2.56 volt. Okay, so this is the VREF that you can choose from. Okay, either from AREF, VCC, or 2.56. Okay, what about the ADC input channel? Okay, to select the ADC input channel, okay, you can do it by select at this bit here, bit 0 sampai bit 4. So this is your marks. Okay, since now we are going to do the single channel, okay, so you need to refer to this table lah, okay, for the single-ended channel. For example, if you put your sensor dekat port A, pin number C, so this is the value lah that you're going to put inside of your marks. Okay, 0, 0, 0, 0. If your sensor is, you put it, okay, you connect it to port A, pin number 5. Okay, so here is where you're going to select, okay, initialize your channel, which is 0, 0, 1, 0, 1, okay, which is you're going to use the ADC 5. Okay, so ADC 5 is located at port A, pin number 5. Okay, make sure that you set up, okay, you do the settings for the channels here, the single-ended channels here correctly. Okay, so that is for the step number 3. Okay, so this is where you're going to select the channels here, ADC channel. Okay, and then after we finish step number 3, step number 4, okay, you're going to start the ADC conversion. Okay, how to start the ADC conversion? Okay, to start the ADC conversion, there is 1 bit inside of ADCSRA. If you put 1, the ADC will start immediately. Okay, so the bit here is at this bit here. So this is where you're going to put your ADC, sorry. Okay. ADSC, silap ya, ADSC. Okay, so you need to put 1 here, then after that, you already start the ADC conversion. So how to make your ADSC equal to 1? Okay, to do that, okay, you can simply write this code here, okay, which is ADCSRA, okay, which because the ADSC is inside of ADCSRA, and then do a masking. Okay, why we're going to do this masking here? Because previously we already set the conversion speed and enable the ADC, so we don't want this bit here. Okay, this bit here. Okay, we already set this bit. Okay, now what we're going to do is we need to make sure that this bit, the value in this bit here is remain. Okay, so what you're going to do, so that's why we need to do this masking. Okay, so that's why ADCSRA equal to ADCSRA. You do a logical OR and put 1 to this bit here, to a location of ADSC. So what happened here is, so previously, okay, so you have this value here. When you have, okay, for example, I put this X, which is a don't care, okay, whatever value that we set earlier, and this is kosong lah, okay. And now we're going to, previously this one is kosong. Okay, so this is the original number. This is after you did the step number 2. Okay, now you're going to OR with this bit. Okay, so this bit here, when you put 1, okay, or shift, okay, this value here 1 to a location of ADSC. So what happened here is you're going to OR with this value. Okay, when you do this ORing here, so what happen? This bit already been set, and others bit the value is remain. So this is what happened in the step number 4. Okay, only bit 6 sahaja yang kamu set, while the remainder of the bits follow the previous value. Okay, so that's why we do the masking here. Okay, so this is step number 4. Step number 5, okay, you are going to look at this ADIF. Kenapa nak tengok ADIF? Because we're going to see whether the conversion is finished or not. Okay, so that's why we're going to look at ADIF. So where is the location of this ADIF? So ADIF is located inside of you punya ADCSRA. Okay, around here, somewhere around here. Okay, so now what we're going to do, macam previously okay, when we did the timer, okay, we're going to look at the TOV flag or CF flag. But now for the ADC, you are going to look at the ADIF flag. So how to monitor the ADIF flag? Okay, similar to what we did in the timer programming. Okay, you use the while loops, ADCSRA, and with this ADIF, okay, the flag that you're going to look at, is it equal to 0? If yes, it will keep monitoring. Okay, means that the conversion is not yet finished. Okay, when the ADIF equal to 1, so what happened here is, okay, this value here no longer, this condition no longer true, and it will exit from this while loops. Okay, so that is step number 6. Okay, what is step number 6? Okay, you're going to read the ADCL and ADCH value. Okay, the result that we've been placed to ADCL and ADCH. Okay, you're going to take the result and put it to your output port to display the value of the ADCL and ADCH. Okay, so that is the polling method. Any question up until here? Ada soalan tak? So this is what you're going to do lah. Okay, for the ADC programming using a polling method. Okay, if no question, okay, now we're going to look at these examples here. Okay, we have this is your ATmega 32 chips. Okay, so this ATmega 32 chips, okay, you see here, okay, you have LEDs, okay, 16-bit LEDs that are connected to port B and port D. Okay, so this 16-bit LED is used to display whatever value after you do the ADC conversion. Okay, you see here, this is your ADC. Okay, you have the ADC channel 0 connected to this potentiometer. Okay, your punya rheostat. Okay, so this rheostat, okay, you will vary the value of the resistor, and that value will be displayed on these LEDs. Okay, why we need to have 16 LEDs? Okay, why we need to have a 16 LEDs? Why? Because ATmega 32, the ADC is a 10-bit ADC. Okay, so you need to have a 10 LEDs to connect to show the value after the ADC has complete. So that's why we need to have 2 port here, which is port D and port B, to display the result of the digital D out here after you did the conversions. Okay, so this is what happens. All right. So now we are going to look at this step programming. Okay, using a polling. Okay, this is this program here is what use. Okay, this program here is to do this things lah. Okay, the one with that we look at this diagrams here. Okay, but this one here, this is using the assembly language. Okay, we're going to focus on the C programming only. Okay, kita tak nak tengok kat assembly language. Okay, we just skip this part here. Okay, and then we're going to look at this here. Okay, so now let's check one by one what happened here. Okay, mula-mula. Okay, what you're going to do here is, right, first, macam biasalah. Okay, we need to include the AVR. Okay, so include avr/io.h. Okay, and then after that, okay, because we don't want to use any interrupts or anything, okay, just include this file is more than enough. Okay, and then after that, we started with main program. Okay, and now we're going to look at what is the program inside of this main program. Okay, first, step number one. What is step number one today? Okay, we're going to initialize the ADC inputs. Okay, since ADC input, okay, based on this connection here, okay, we can see here, okay, this rheostat here we connected to ADC kosong, okay, which is this is a port A pin number 0. So why not? Okay, we initialize the whole port A as an input port. Okay, so initialize the whole port A as a input port. So this is your first step. Okay, enable or initialize the ADC input channel, which is on your port A. Okay, and then we need to initialize the input output port lah. Okay, in this case, okay, we have a port B and port D connected to LED. So initialize your port A and port D sama dengan, okay, DDRB equal to OXFF and DDRD equal to OXFF. Okay, so you already initialized the input port for the ADC and other port for the outputs. Okay, now we're going to look at step number 2. Okay, what is step number 2? Step number 2 is enable the ADC and select the conversion speed. Okay, so we're going to enable the ADC. Okay, to enable ADC, we need to enable it inside of ADCSRA, kan? So you put ADCSRA. Okay, sama dengan 0B. Okay, using a 0B. Okay, enable. Which bit that you're going to enable? Bit 7. Okay, so you put 1 on the bit 7. Okay, because previously, okay, we found out to enable the ADC, okay, you need to enable at this bit. Okay, so this bit, this is your add-in, okay, to enable the ADC. Okay, so that's why bit 7, you give 1. You need to start the conversion. This is your ADSC. Not yet. Okay, so you give 0 here. What about this one, this, and this? Okay, so this bit here, you just simply give a 0. Okay, what about this bit here? Okay, so this bit here, you need to find out what is the prescale option lah untuk yang ini. Okay, sebab let's say lah, okay, in this example, not given what is the external value. Okay, so we just follow the value here. Okay, the value here, it gives 1111. Okay, so what you see here, 8787 convert to binary, you will get 10000111. Okay, so now you know that. Okay, here is what happened here is you use a 1 to 8 Prescaler. Okay, if the STL is given, then we need to find out lah. Okay, what is the value to be put inside of this prescale here. Okay, in order to make sure that the frequency is less than 200 kilohertz. Okay, so this is step number 2. Okay, and step number 3, what is step number 3? Okay, you're going to select your VREF ADC input channel. Okay, so this one here, you can do it inside of add marks. Okay, using a 0B. Okay, so sekarang ni dia ada bagi tahu tak guna what kind of a VREF here. Okay, not telling us what is the VREF that we're going to use. Okay, but according to these examples here, okay, the VREF here is 2.56. Okay, let's say you're going to use a 2.56 VREF. Okay, so 2.56, so this is your add marks. Okay, now you're going to do a setting at this bit here. So this is your RF and this is your marks. Okay, this is your VREF or RF. Sometimes we call it as RF. Okay, now we are going to use the 2.56. Okay, so 2.56 is 1 1 lah. Okay, 1 1. Now you're going to use a 2.56. Okay, which is the internal VREF. So you put 1 1 in this bit here. What about the ADLA? Okay, so for the ADLA, we always use the right justified lah. Okay, for the right justified, simply put 0. And if you're going to put it to left justified, then you need to put 1 lah. Okay, set it as a 1. Okay, what about your marks? Okay, your channels. Okay, now we're going to look at here. What is the value for this one? Okay, since we are going to use a ADC kosong, this is a single channel. Okay, so ADC kosong single channel. Okay, you need to refer to this here. Okay, ADC kosong single channel. So you need to put this value kosong 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 kosong. Okay, so kosong 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 kosong. So you know that this is a VREF equal to 2.56 and with ADC 0 channel use. Okay, so that's why you can see here the value here is C0. Okay, so this is when you change this value here from binary, you will get C0. Okay, so that is a step number 3. Okay, next step number 4. What is step number 4? Okay, step number 4 is you're going to start the ADC conversion. Okay, how to start ADC conversion? By put 1 to your ADSC. How to do that? Okay, you can simply put ADCSRA sama dengan ADCSRA. Do a masking because previously we already set this value here to our ADCSRA. So we don't want to lose this value here. So that's why we do a masking and do a logical OR with this bit here. Okay, so sama dengan okay, put 1 at location of ADSC. Or if you don't want to use this one here, okay, you can simply write ataupun ADCSRA sama dengan ADCSRA or with 0B01000000. Also same, benda yang sama. Okay, so this one is similar to this one. Okay, that is step number 4. Step number 5. What is step number 5? Okay, you're going to monitor the ADIF, okay, your ADC flags. How to monitor ADC flag? Okay, by using the while loop. While, all right, and then ADCSRA because the ADIF is inside ADCSRA and with ADIF. Okay, and check whether it is sama dengan kosong ataupun tidak. If yes, it will keep looping here. If not, okay, if the ADIF equal to 1, so what happens? It will exit from this loop. And what you're going to do? And last but not least, step number 6, okay, which is, okay, you're going to read the ADC, L and ADCH. Okay, so macam mana nak buat? How to read? Okay, you need to look lah dekat you punya LEDs. Okay, now our LEDs is connected to port B and port D. Okay, this port B is your least significant bit. And this one is a most significant bit. Okay, so what you're going to do here is port B sama dengan ADCL because we decide that port B is the least significant bit. Okay, the least significant bit is inside of ADCL. Sebab why? Because we are using the right justified. Okay, so this is a 16 bit. Okay, so this is your ADCL. Okay, 8 bit dah digunakan, and then you have another 2 bits here. This is ADCH, and this is a unused bit. Okay, because we're using the write justify. Mana tadi? Here, write justify. So this is how the D out, okay, is being saved inside of ADCL and ADCH. Okay, so that's why port B sama dengan ADCL. Okay, but this one here, if you can see here, port D become your lower ni lah, your least significant bit, while port B become your high significant bit. Okay, so now port T sama dengan ADCH, and then we stop. Okay, close the curly bracket, and this is your main program. Okay, but bear in mind that okay, this ADC conversion only happen once. Kenapa berlaku sekali? Sebabnya kalau kamu tengok, okay, the program is flow from top to the bottom, and then it's end here. Okay, how to make this ADC conversion, do it continuously. Okay, how to do that? Okay, to make sure that the ADC conversion do continuously, okay, you can put a while loop. Okay, kat mana kita nak letak while loop? In between step number 3, okay, sampai sini. Okay, so this is where you going to put a while loop. Okay, between step number 3 and then after that step number 6. So it will keep repeating. Okay, after it finish, hantar dia punya value to ADCL and DCL, and it will start again the conversion. Monitor the flags. If the flag is equal to 1, means that the conversion is finished. Put the value to the ADCL and DCH, and then start the conversion again by put 1 to your ADSC. So this is what happens. Okay, any question up until here? So this is how to do the ADC by using a polling method. Ada soalan tak? Okay, tak ada soalan ya? Okay, great. So now we're going to look at okay how to do a program for the ADC, but now using interrupt method. Okay, so this is what I'm going to do for the interrupts. Okay, so this is the step lah. Okay, mula-mula for the ADC interrupt, the first step that you're going to do is include the interrupt header, which is hashtag include avr/interrupt.h. Okay, because we are going to use an interrupt, so we need to include this header here. Okay, that is the very first step, which is quite similar to what we did in the interrupt programming. Okay, so every interrupt you need to include this header file. Okay, and then step number 2, initialize the ADC input. Okay, you need to initialize your port A as a ADC input channels, and then other GPIO input output. Either you're going to make input or output ports. And step number 3, okay, so you have an enable ADC, and then you need to do this thing here. Okay, another additional thing here, which is ADIE. Okay, you need to enable the interrupt ADC. Okay, so this interrupt ADC select conversion speed. Okay, you can do it inside of ADCSRA. Okay, kat mana pula tu? ADIE. So ADIE, okay, you can enable it dekat sini. Bit number 4. This is where you punya ADIE. Okay, so you need to enable this. So you have 2 enables lah. One, your ADCs. The second one, you need to enable the interrupts. And of course lah, if you enable the interrupt, then you need to enable the SEI as well. Okay, SEI. Okay, enable the I flag inside of the status register. Okay, don't forget to enable this I flag inside the status register. All right, next, step number 4. Okay, select the VREF and ADC input channel. Okay, so this one here, you can done it inside of your add marks. Okay, to select the VREF and ADC input channel according to where you put your sensors. Okay, so step number 5, enable SEI. Okay, so now, okay, this is go to the step number 5 lah. SEI, you can put it under here also can, or you can put it in step number 5. Okay, but follow lah this step is better, right? So enable the SEI. Step number 6, start conversion. Okay, how to start conversion? Okay, give 1 to your ADSC. Dekat mana? Dekat ADCSRA register. Okay, do we need to monitor the flags? Okay, no need. Why? Because this one here, to monitor the flag will be done by the CPU. Okay, you no need to do these things here. Okay, yang ni tak perlu buat. Okay, no need to monitor this ADIF. So this ADIF will be automatically done by the CPU. Okay, and last but not least is step number 7. Okay, which is you need to create the ADC interrupt service routine. Okay, make sure that the name is correct lah. Okay, so this is your ISR. ISR underscore ADC underscore vet. Under this ISR, okay, you need to read the ADCL and ADCH value because we already finished the conversion. Okay, you need to read that conversion and put it to your port output ports, and at the same time, you need to start your conversion again. Okay, so this is what happened here. Read the ADCL and ADCH value and set your ADSC sama dengan 1 so that you can start the conversion again. So this will be done continuously. Okay, so this is for ADC interrupts programming. Okay, so this is the things here. Okay, so this is the another recall lah. Okay, for the ADCSRA register. So this is where you're going to enable. Okay, this bit. Okay, you need to enable the interrupt, ADC interrupt. Okay, in order to use the interrupt programming. And okay, kenapa dia ada 2 kali ni? Okay, so we just skip this one. Okay, and this is your interrupt vector table lah. So for the ADC, okay, so the interrupt vector table is down here. Okay, means that this ADC interrupt is lower priority compared to your external hardware interrupt and compared to your timer interrupt. Okay, if the INT is being requested at the same time of your ADC, so INT will be triggered. Okay, ADC will not be triggered because it has a lower priority. Okay, so this is a same. This is the program by using the assembly language. Okay, the same what we did earlier, yang this one. Okay, but using what we call here assembly language. Okay, now we are going to focus on the C programming. Okay, yang ni. Alright, so now, okay, I just write down sebelah ni. Okay, so that we can compare it. Okay, the difference between the what we call here polling and interrupt for ADCs. Okay, yang ni tadi polling. This is a polling method. Okay, now we are going to do a interrupt method. Okay, the same example that we're using. Okay, which is you have a ADC 0 connect to your restart and the value, okay, the hasil of the conversion, ADC conversion will be displayed on the LEDs connected to port port B and port C. Okay, so now step number 1. What is step number 1? Okay, you need to include, okay, so this is step number 1. Include avr/io.h and include another file called avr/interrupt .h. Okay, so this is the things lah. Okay, you need to include this file. Okay, for the interrupt, ADC interrupt. Okay, next, what are you going to do? Okay, lepas tu, after the step number 1, okay, step number 2. What is step number 2? Okay, you're going to initialize the input-output port, which is similar to this one. Okay, you start with your int main void, start your main program. So under your main program, you initialize your DDRA so that your DDRA become an input port. Okay, you're going to put your sensors here, so make sure that your DDRA become input port. DDRB, set it as an output port, okay, because you have a LEDs connected to port B and port D. So this both port here, you make it as a output port. Okay, so this is step number 2. Okay, now step number 3. Okay, what is step number 3? Okay, step number 3 here is enable the ADC, ADIE, and select the conversion speed. Okay, so how to do that? We can do it inside of the ADCSRA. Okay, use a binary representation for easy settings. Okay, enable ADC. Okay, ADSC will give 0. Added also give 0. And this one also, the ADIF also 0. What about ADIE? Okay, so now you're going to enable this bit here. Okay, you need to put 1. Okay, so this is your ADIE. Okay, enable the interrupt. Then next, okay, previously we're using a 1 to 8 prescaler. Okay, so what would be the value? The value for the 1 to 8 prescaler is 1, 1, 1. So this is the value that you're going to put inside of the ADCSRA. Okay, you enable the ADC. So this is your addend. Enable the interrupts, and this is the prescale of 1 to 8. Okay, next step number 4. Okay, what is step number 4? Previously we need to monitor, kan? Okay, now we don't need to monitor. Okay, sorry. Previously, after you enable this one here, this bit here, you need to do the VREF lah. Okay, so similar to this one here. Okay, step number 4, you're going to select the VREF and ADC input. So this one you can be done inside of AdMarks. Okay, next we are going to use the VREF equal to similar what we did earlier, which is 2.56 volt internal VREF. So 0B110, and we're going to use a right justified. Okay, so we just put 0 here. What about the channel? Channel, since the sensors, okay, the rheostat, the potentiometer, we put it to ADC 0, so the value will be 0, 0, 0, 0. Okay. If you connect the what we call here the potentiometer to ADC 7, so then next, then what you need to do is kena tukar lah this value, okay, according to channel ADC channel 7. Right, so this is step number 4. Step number 5. What is step number 5? Okay, step number 5, you need to enable the I flag inside of your status register. So how to do that? By putting the SEEE here. Yes, step number 6. Start your conversion. How to start the conversion? Okay, give 1 to ADSC. So how to do that? Okay, by give this ADCSRA and do a masking. Okay, why? Because we already have the value here inside of ADCSRA. Okay, in order to make sure that this value is not cleared, okay, or altered, okay, we need to do the masking and or with this value here, ADSC. Okay, so this is where you're going to start the conversion. Okay, after you finish execute this line, the conversion is started. Lepas tu nak buat apa pula? Okay, next what we're going to do, we need to monitor dia punya until the interrupt trigger. How to monitor? Using a while loop lah. Okay, while loops 1, and inside of while loop do nothing lah. Okay, because we have nothing to do. Okay, there. So, and last but not least, step number 7. Okay, so this is another step. Yeah. Step number 7. Okay, you need to. What apa step number 7? What is step number 7? All right, step number 7 is you need to, okay, create the ISR for IDC. Okay, so ISR ADC underscore vet. Okay, what we're going to do inside this ISR here. So, mula-mula hantar the value to your port B and port D. So, port B sama dengan ADCL. Okay, let's assume that port B is your lower byte and port D is a higher byte. ADCH, and last one here. Okay, we're going to start again the conversion. Okay, how to start? ADCSRA equal to ADCSRA or with ADS. Okay, so this is the things that you need to write in the interrupt service routine for ADC. Any question up until here? Okay, we already finished the interrupt ADC programming by using interrupt method. Ada soalan tak? Semuanya okay? Okay, good. Okay, now we're moving on to this slide here. Okay, so this is the jawapan tadi lah. Okay. Yang kita buat, tapi untuk this one here dia tak, okay, kamu kena buat, okay, dia letak ke atas ni ya, dia punya ISR. Okay, you can put it up here or you can put it down here, no problem. Okay, now what we are going to do here is, okay, we're going to look at this examples, okay, this exercise here. Okay, so let's look at this exercise. Okay, refer to the flowchart in this figure here. Okay, the program is running on 4 MHz. Okay, give it that the STL sama dengan 4 MHz. 4 MHz. And frequency at mega that reads continuously a single-ended. Okay, telling us, okay, we are going to use a single-ended input from ADC kosong. Okay, again, you put a sensor at ADC kosong and the conversion will be done continuously, which is set with an ADC frequency of 62.5 kHz. Okay, di mana from this external, okay, you're going to set the frequency, ADC frequency to 62.5 kHz. Okay, and while using a voltage of, okay, 2.56 volt. Okay, the Vref sama dengan 2.56 volt. Okay, so what you're going to do? Okay, see here, read the ADC. Then initialize a port B as an output, initialize port D as an output, initialize port A as an input. So you just follow this flowchart here, do the programs. Okay, enable ADC, select the prescale of 64. Okay, if you divided 4 MHz with a 64, you will get, okay, 4 MHz divided with 64. Okay, you get 62.5 kHz. So that's why you need to use a prescale of 64. Okay, which is, you know that the tadi kita buat F new, okay, or FFDC sama dengan F bahagi prescale. Okay, now you don't know what your prescale is. Okay, so what happened here is prescale sama dengan 4 MHz divided with 62.5K and you will get, okay, you will get 64. Okay, so this is the prescale option that you're going to use. Okay, so now we're going to write the programs. So macam mana nak tulis program ni? how to do that. Okay, based on this information, okay, mula-mula you find out the prescale. Okay, the prescale is 64, and now after that you can start the programs. Okay, so first, okay, let's assume that this is using okay, it's telling us that this is using the interrupt. Dia dah bagi tahu kat situ return from interrupt. So you're going to use the interrupt programming for ADCs. Okay, so interrupt programming, first, what you're going to do, okay, include this file here. Okay, and then hashtag include avr/interrupt.h. Okay, so you need to include this file. Okay, and then you can define your CPU for 4 megahertz. Okay, how to define hashtag def_CPU. Okay, 4 million. Okay, so this is how you're going to define the CPU speed. And next, okay, you started with your main program lah, int main void. Okay, so under your main program, what you're going to do, so this is where you going to do the step number 2, which is initialize the ADC inputs. Okay, so this is the port that you're going to initialize. DDRB sama dengan OXFF. DDRD sama dengan OXFF. Okay, you make both port B and port D as output port, and at the same time make a port A as a input ports. Okay, and this is step number 2. So this is step number 2, this is step number 1. Step number 3, enable the ADC, ADIE, and select the conversion speed. Okay, so you can then do this inside of the ADCSRA. So what will be the value? 0B1, 0, 0, 0, and 1, okay, to enable the interrupts. And what about the prescale? Okay, for the 64, the prescale is 1, 1, 0. Okay, so this is the value that you're going to use. Okay, next, step number 4. What is step number 4? Okay, step number 4 here is you're going to select the VREF and ADC input channel. Okay, you can do it inside of the add marks. Okay, what would be the value here? 0B. Okay, since using a 2.56 volt, so 110. Put your ADLA to right justify. And what about the input channel? Input channel, since you're going to use the ADC kosong, so 0, 0, 0, 0, 0. Step number 5. Okay, nombor 5, enable the SEEE. Okay, enable the I flag inside of your status register. Step number 6, start the conversion. Okay, ADCSRA. Okay, sometimes this is the shortest way lah to do the masking. Logical OR. Okay, sometimes we can. Okay, so this is the shortest way lah to do it. Okay, to do the masking, which is it is equivalent to ADCSRA sama dengan ADCSRA. Do a logical OR with this value. Okay. Next. Okay, under while loop. Okay. So while loop, it will keep monitoring forever. Okay, because you're going to do it continuously, so it will keep monitoring the ADIF. Okay, once finished. Okay, so what happened here is, and step number 7, then after that you need to do the ISR, because we are going to do the interrupt service routine. Okay, ISR ADC underscore back. Okay, make sure the name of this interrupt service routine is betul lah. Okay, so under this one here, okay, so this is what happened. Okay, send a lower byte to port B. Okay, dikata kat situ, lower byte to port B. Okay, it means that port B will get the value from ADCL, and port D will get the higher value. Okay, set high by to the port D ADCH, and then next. Okay, don't forget to start again the conversion because you want to do it continuously. Okay, so ADCSRA sama dengan ADCSRA, do a logical OR with this value ADSC. Okay, so that's it. So this is the solution for this question. Okay, any question up until here? Okay, this is by using the what we call here assembly language. Okay, we no longer using the assembly language. Okay, we are writing in the C program. Okay, if no question, then we move on to the next slide, which is okay. This is a digital to analog conversion programming. Okay, for the digital to analog converter, okay, or something we call it a DAC. Okay, so this DAC is widely used to convert the digital pulse to analog signal. Why? Okay, because our real world is an analog system. Okay, in order us to hear the voice, okay, we need to hear it in an analog system. That's why we need to convert back the digital value that is processed by the microcontroller to the analog signals. Okay, there are two methods of creating a DAC. Okay, the first one is by using a binary weighted, and the second one by using R to R ladder. Okay, so this is able to achieve higher degree of precision. Okay, now we want to look at this R to R ladder. Okay, so for this R to R ladder, okay, we're going to use this what we call here ICs here called a DAC0808. Okay, so the DAC0808, the digital input are converted to the current out. Okay, we call it as a I out, and by connecting a resistor to the I out, we convert the result to the voltage. Okay, so that's why it's called a R to R ladder, because you're using a resistor, okay, to convert the digital value back to the analog inputs. Analog outputs. Okay, so this is the formula here. I out sama dengan I ref. Okay, so you need to have a I ref here, and the first bit here is divided by 2. Second bit divided, bit number 7 is divided by 2. Bit 6 divided by 4, while bit 0 here will divide by 256. Okay, so let's look at these examples here. Before that, okay, your IRF is the input current that must be applied to pin 14. Okay, so look back at pin 14. Mana kita punya pin 14? Okay, here. Satu. Okay, kat sini nanti. Okay, so here you're going to put your IRF on the pin 14. Okay, so assuming that the R sama dengan 5 kilo ohms, okay, you're given the R equal to 5 kilo ohm, and IREF, okay, the current reference is 2 milliamp. Okay, you're going to calculate the V out for the following binary input. Okay, you're going to find out what is the I out for, not V out, yeah, this is a I out. Okay, for the following binary numbers. Okay, so assume that the first one here we have 1001, 1001, which is equivalent to 99 hexadecimal, and the second one here is 1100, which is equivalent to C8 in hexadecimal. Okay, so solution here, first, I out sama dengan 2 milliamp, okay, which is your IREF, okay, and then now this value here, all right, so you need to divide it, this value you need to change to decimal. Okay, you can change by using the calculator, or you can calculate darab dia punya weightage. 1, 2, 4, 8, 16, 32, 64, 128. So this one here is a 128 tambah dengan 16 tambah 8 tambah 1, you will get 153. Okay? Betul tak? 128 tambah 16 tambah 8. Okay, so 153. Okay, and then since this one here you need to divide it, betul tak? Okay, the maximum value here is 256. Okay, make sure that you divide it with 256 lah kat bawah ni. Okay, so this is what happened lah. Okay, so that's why we darab dengan wastage tadi, because this is 1, 2, 4, 8, 16, 32, 64, 1 to 8. Okay, so 256 you have to, nak jadikan 256 kamu kena darab dengan 128. Okay, so it will become 256. Okay, so now what we're going to do here to achieve here is, okay, make sure that the pembawah here is 256, and then this one here, this is what we call here the decimal representation from this binary value. Okay, then you get the I out. So this is the I out lah. 153 bahagi dengan 256, you will get 1.195 milliamp. Okay, now, okay, we're going to calculate the V out, sorry. Okay, you're going to calculate the V out by using the V sama dengan IR. Okay, which is I you already have 1.195 milliamp. Your resistance is 5 kilo ohm. Okay, so you multiply with 5 kilo ohm, then you will get 5.975 volt. So this is the representation for this value lah. Okay, if you have this value here, 99 hexadecimal, okay, actually in analog, the value is 5.975 volt. Okay, and another one here, okay, another example. Okay, so this is the binary representation, which is C8 in hexadecimal. So what you're going to do here is tukarkan dahulu this one to decimal. Okay, so you will get 200. 200 divided by 256, multiply your IREF, you will get I out. So this is your I out. And to get your V out, sama dengan you using this formula, V equal to IR. So 1.562 multiply with 5K, you will get 7.8125 volt. Okay, so this is in binary representation for save. Okay, and this is the analog input, 7.8125 volt. Okay, and last but not least is a sensor interfacing. Okay, any question for the digital to analog converter? Okay, we just use this DAC0808 circuit. Okay, if no question, then we go to the sensor interfacing. Okay, this one here you can read it. Okay, I will give you the what we call here, okay, the article for you to read it for that sensor interfacing. But to conclude it, okay, so this is how you're going to what we call here to interface, okay, your sensor with ATmega32. Okay, let's say lah you have these sensors here. Okay, so these sensors have 3 pin out, which is a VCC, ground, and V out. Okay, you have a sensor here. So this VCC here must be connected to VCC, and ground must be connected to ground. What about V out? V out is actually your V input to ADC. Okay, you can use the ADC kosong. Okay, if you use the ADC kosong, make sure that under the add marks, okay, you pilih channel kosong. Okay, if you connect this one to ADC's 5, for example, okay, make sure that inside of the add marks, okay, you need to set, okay, the value for ADC 5. Okay, and if you, this is for the what we call here, single-ended sensors or single-ended channel. Okay, if you have the sensor have 2 legs here, which is V out 1 and V out 2. Okay, so this is where you're going to use the differential punya channels. Okay, so one you put here, and the second one you need to put any ADCs according to this table here. Okay, sama ada you going to use a gain or not. Ini. Okay, so this is by using the differential inputs. Okay, for gains, okay, make sure that you pilih this one lah. Okay, you summon your sensor at this location here. Okay, if not, okay, you just use this one. Okay, if you don't want to use any gains, okay, just put your inputs, okay, of your sensors to these locations. Okay, so that's all for today. Any question for ADC? We already finished the ADC part.